The next presentation will be Eitan Levy with Emefcy.
Oh, you are tall. Good evening. Do they really hear us in Boston and see us? Oh. It does. I don't see any screen, but I believe you. I trust you, Jim. So, hi, Jonathan, wherever you are. I'm going to present our company, Emefcy, and our new technology to utilize the organic material in wastewater as a source to generate electricity by special bacteria that convert the organic material into electricity. I'll start with the bullets and then go to the details. We are directly convert the organic material into electricity, a low-cost electricity, around 10 cents per kilowatt hour, or alternatively into hydrogen, again low-cost hydrogen, about $1.5 per gallon of gasoline equivalent, through a bioelectrochemical process. We are converting wastewater treatment plant for heavy energy consumers into energy neutral, or in many cases energy positive. It means that we are converting wastewater treatment plants into power generating plants. And the power that we generate is carbon free, and it's distributed and continuous. If there are viewers in the West Coast in the US, in California, they well know the problem of distributed power, that where the power is available, there are no transmission lines, and we need the power generation units in the populated areas, and that's what we are doing. Our power generation is distributed. We are the first company in the world to commercialize this technology. In fact, it's quite intensively studied in the academia, but no company so far taking the next stage to commercialize it. So we are the first mover in this market, hoping that when we are going to start selling in about 2 years' time, we are going to be the world market leaders. And myself and my partner, Ronen Schechter, are experienced entrepreneurs. For those of us who know us from Aquise, it was our previous venture, and we are now involved in Emefcy. And we believe that our experience and contacts will help us to bring this idea into reality. So these were the bullets, and I'm now going a little bit into details. So there is a paradox in wastewater treatment. Wastewater is theoretically a source of energy. They contain organic material that can be converted into electricity or into any other source of energy. But in 95% of the cases, we spend a lot of electricity or a lot of energy to get rid of this organic material instead of utilizing it. And our idea is to change this paradox and to utilize this energy. In the US only, the electricity bill of the wastewater treatment plants is $1.6 billion a year. We can offset a major part of it and convert it into the other side, selling the electricity into the grid instead of buying electricity from the grid. There are some processes for utilizing energy from wastewater. Those of you that heard about anaerobic processes, but they are very sensitive to the wastewater conditions. So when the wastewater are saline, or if they are high suspended solids or fats or grease, those processes are inhibited. And that's why they're covering only 5% of the potential market to utilize energy from wastewater, and we are addressing the remaining 95% of the market. So our market focus is to upgrade existing industrial aerobic wastewater treatment plants, and there are tens of thousands of those in the world, by installing our systems inside or next to the existing wastewater treatment plant. That's how the process looks like. These are the bacteria, the electrogenic bacteria, that as they consume the organic material, they generate electricity, and through those tiny nanowires, they transfer the electrons into the cycle, and that's how the electrical cycle looks like. those of you that want to see a little bit deeper how it works, I invite you to visit our presentation at YouTube. You just hit the company name Emefcy at YouTube and you will find it as the first result. It's a 3-minute presentation and it will enable you to understand how it works because it's quite complex, how the electrons and the protons and the organic material are moving from side to side. That's how the full-scale system will look like. We're installing it into an existing or into a new basin. We are installing prefabricated modules in place, and there are 3 main systems here. The hydraulic system that supplies the wastewater from bottom to top, the electrical system that collects the current, and the electrical management system that steps it up into a usable voltage. The breakthrough is the ability to implement low-cost industrially available materials into this process that was so far just a matter of research in the academia. We are not using platinum. We are using only biocatalysts. The bacteria are the catalyst of the process. We are not using membranes. The process doesn't utilize any membrane. So by our proprietary low-cost materials, we can make this process very applicable. The benefits for the customer are energy-efficient wastewater treatment, carbon-free power generation, which means also carbon credits according to the Kyoto CDM mechanism, very low yield of excess sludge. Sludge, as you may be aware of, is the major pain of wastewater treatment, and while conventional processes generate 50% sludge out of the organic material being treated, our process generates just 7% sludge. That means 80% reduction in the amount of sludge to be treated and removed. And the bottom line is a high return on investment, about 3 years payback time in most of the applications, which brings a very attractive solution to the customer. And that's how the economics look like. There are 4 sources of income: the credits of saving generation, the sales of the electricity, the saving from sludge, and the carbon credits. And they are offset by the cost of the installation. So the net customer value is $8.6 million in this case of a $13 million income. The bottom line is 27% IRR split into these 4 sources of income. As I mentioned, our initial market focus is in aerobic industrial wastewater treatment market. We already signed 3 letters of intent with customers, with the Teva Pharmaceutical, with Gadot Biochemistry, and with Nova. Here I said that we are currently negotiating, but these negotiations are now going forward because we started already testing the wastewater. We intend to develop a network of representatives, as we did in our previous venture in Aquaise, so we know quite well how to approach the market. And we intend to sell a turnkey project on the basis of a process package where we are going to provide the critical components, the electrodes and the management system, and partners or subcontractors will do the local installation works, civil works, piping, electrical works, and so on. Of course, that the BOT projects or profit sharing with the customers can be an alternative process model as well. Our market size is quite large, over $10 billion in the existing fleet of industrial wastewater treatment that are applicable for our technology. And as I mentioned, myself and my partner Ronen are experienced in this business. We have a very strong scientific advisory board of 3 US-based professors that are specialized in research of different aspects of this technology. And we are in almost daily contact with the advisory board, with the questions and answers and assistance, and it's a wonderful cooperation. For those of you in Boston, one of the members of our board is Derek Lovely from University of Massachusetts in Amherst, an excellent microbiologist. We are currently already 6 full-time employees and 2 part-time employees. We are raising now $5 million with an option to break it down into 3.5 and 1.5. That will take us to a full-scale working beta site. We plan to be break-even in 2013. Our current investor, our seed investors are Israel Cleantech Ventures. And as I mentioned, we expect to raise very soon between $3.5 and $5 million. Our timeline is this year, which is ending soon. We're in lab research. Next year, we are going to start field piloting with those customers that I already mentioned. We will build our first full-scale demo plant in 2010, and we'll start selling in 2011. That's more or less our story. Yes, please. Yes. Only biodegradable organic wastewater. The question was if we are only treating biodegradable organic wastewater, and the answer is yes. If it is heavy metals or, of course, the salination and so on, this is not our field of business. Wastewater treatment means biological wastewater treatment in most of the cases. Yes, please.
What is the size of your footprint? You talk about integrating into an existing system or adding in mind another system?
The question was what is the footprint size of our systems and if they can be implemented into existing plants. The answer is yes. The rate of reaction in this biological chemical reaction is quite high. So we can decrease the size of the reactor. So by taking a slice from the existing reactor, like I give you a quantitative example, if we are taking 20% of the existing reactor, in this 20% we can remove about 60% of the load. So the remaining 40% should utilize only 80% that are left of the volume of the reactor, which means that we are saving a lot of footprint here. One more question, the Jean allows us? No more questions. Okay, thank you very much.